Hi, everyone. Welcome to the new and last episode of the podcast series When Machine Learning Meets Privacy. I'm your host, Fabiana, and I had the pleasure to produce this podcast for the MLOps community, a great place where, besides content, you can have a chat or two with great minds from whom you can learn more about MLOps and other topics. This series was sponsored by Y Data, and we provide the first data experimentation platform so data science teams can build the best data sets for machine learning with tools such as data quality profiling, data labeling, and synthetic data. And as this is the last episode, I couldn't help myself but to bring you a very special one. To talk about synthetic data, its benefits, and how can we, and we are already leveraging synthetic data, I've invited not one, but two brilliant minds. With me, I have Jean-François Rajotte, researcher and resident data scientist at the University of Columbia, and Sumit Mukherjee, senior applied scientist in Microsoft's AI for Good Research Lab. So, hello, Sumit and Jean-François. First of all, I want to welcome to the podcast and also thank you for being here and helping the community to understand the potential, the benefits, and challenges of using synthetic data and the context of privacy. Both of you have impressive resumes, and so it's always a great pleasure to count with both for this session, of course. Jean-François, you are a brilliant researcher in the UBS Data Science Institute. How have you developed a particular interest for healthcare, GANs, and, well, the combination of them with differential privacy?
Actually, it was a long journey. So my background is in physics. Then I did after some years of research in physics. Then I did a transfer to data science. I first was kind of a general data science researcher. My in a in an institute that has the mission to transfer data science from of a more academic level to more to the industry. So and then I moved to Vancouver for family reason actually, but then I joined the Data Science Institute where they had it was a perfect fit because they had also some similar mission also to use the university and then transfer it to either it could be actually to other faculty who would need data science in their work, or it could be also in some collaboration with outside industry also. Well, we had the Data Science Institute had a big focus on health science, so there was already some collaboration going on in the healthcare domain. We noticed very quickly that there was this big need of data exchange, but then it was such a difficult thing to do, going through all the hoops of having approval, signing NDAs. Even now, for example, we have new collaborators who are coming, joining a new project, and then they have to have a special device like their laptop. They connect to this laptop that is there on premise, and that's the only way they can access data. So it's very limiting. It's so limiting that even a still emerging technologies like GANs, generative adversarial network, we are exploring this as a way to generate synthetic data. So this synthetic data can be shared more easily. There's some caveat. You have to put privacy still because, as you know, or as we might discuss, even when you create synthetic data, you might leak some information. You might make some copies almost of the data that you use to train your generator. That's in a nutshell what brought me to this.
Definitely a long way.
Yeah.
Very interesting. Summit, on your side, I think it's inevitable to talk about your focus on using AI for the social good and also the application of machine learning in healthcare, in particular for the Alzheimer's study and neurodegenerative disease. So, can you also tell us more about yourself and what led you to focus on AI in these particular areas?
Thanks for having me on your podcast. I actually did my PhD in computational biology, so I was always interested in health and I started all my degrees are in electrical and computer engineering, so I kind of started out in an allied discipline to AI control theory, kind of working with biological data. Realized that it was a little too model heavy to scale to very large data sets. So I kind of through the course of my PhD, I switched to machine learning, switched to using machine learning to analyze biological data. Healthcare has always been my interest. And so after my PhD, I worked as a research scientist focusing on Alzheimer's. The Alzheimer's piece was a little bit on accident. I had interned at the organization where I later joined full time, and they were at the time working on Alzheimer's. And my role very much was to develop novel machine learning techniques to kind of understand the biology of Alzheimer's. After that, I wanted to do something a little more general, but still in healthcare. And the opportunity came along to join Microsoft at my current team, AI for Good Research Lab. My current team works with nonprofits, which include academic institutes, by providing them with both cloud resources as well as helping them with research by doing research that they need. If it's not clear, this is a philanthropic portion of Microsoft. And even though we are a research team, we come under Microsoft Philanthropies. That's kind of how I got into this team and my current area of work to kind of get deeper into the privacy side of things. I have a very similar story about that as Jean-François. So when I started at my team, the team was really small. We were still kind of trying to identify our focus areas. And one of the focus areas that we determined would be impactful was medical imaging. But we soon understood that getting access to medical images are really, really hard. It's really difficult for clinical labs to share these data sets because they are often considered protected health information or PHI. Similar experience as Jean-François, a lot of times that entails going to premises and working on tiny laptops, or sometimes even that is not feasible. You just simply cannot have access to the data. That was proving a bottleneck. So, we wanted to see what exists in the area of privacy preserving data sharing, and synthetic data generation seemed like a promising area. And then kind of in the process, we learned that GANs leak privacy, whereas some of the more stringent ways of enforcing privacy on GANs, like differential privacy, lead to drastic loss of utility. So we ended up doing original research trying to develop our own methods to generate synthetic data in a way that both preserves privacy and maintains utility. And that's kind of become what I do now. It was very much an accident getting into this, but
It's funny to see that both of your paths, in some ways, they are kind of similar in some aspects. So it's very interesting to see that. And before jumping into each one's solution, at least that you have been researching on how to be able to share healthcare data in a privacy compliant manner, I would like to ask you a question for both. And this is a question that always pops up. What is in the end synthetic data? This is not an easy question, but it's very hard for people within that are touching this new concept to understand in the end what is it. So in a kind of a cocktail party explanation, what is for you guys synthetic data?
for me, synthetic data is basically a machine generated data set or sample which has the same type of features as a real data set or sample, but each sample in the data set does not map to a unique sample in the original data set. So you have some real data set, and then you generate these fake samples which kind of have the same properties as samples in that data set, but they're unique and they don't have a one-to-one mapping with the samples in the original set.
Yeah, I was thinking of Christmas is coming, and how will I explain my family what is synthetic data? So it's good to practice with you. So thanks for the opportunity. I heard it from you. Synthetic data, like the most clearest definition is data that was not collected somehow in the real world. you can think of like super boring example, like just a linear model. It could be like x versus y. You have few samples of this, and then you fit a curve, and then out of this curve, then you can create synthetic data. You just randomly select points on the curve, maybe add some noise around the curve that is similar to the how good you did fit the curve, and then you get these points. On a more slightly more realistic case, you can also think of also two variables like temperature and day of year, and then for and you just collect a lot of them, and then you just, if for some reason you want to have a random realistic day, then you just pick out from the model that you've made, and then you're sure that it's not going to be -30 in June if it's in Canada, for example. So I guess it's a way to get data that looks real without having to bother to collect more than what you have.
Those are two very good overviews on how can this we can, let's say, categorize what is or explain what is synthetic data. Definitely. Summit, I do recall that you mentioned on the ongoing process of using GANs for generating synthetic data, you identified that, for example, the use of differential privacy with this kind of algorithms do result in the loss of utility of the end data, right? And you mentioned that doing your research, and I guess specifically on your article, research article, the PriveGAN, you have proposed a new kind of solution for that. Can you walk us through that solution, a bit of the concept of it?
To kind of like first like talk a little bit about what existed before us. So prior to PrivGAN, this area is pretty new. So the only solutions that I am aware of were a few differentially privacy-based approaches to training GANs. What that did was add noise during the GAN training process in a very systematic way, which made it so that any one sample did not contribute very much to the final model. And that's kind of like crux of what differential privacy guarantees, that if you take out one sample, your output would not change much. And in this case, the output is the model parameters. So it's a very strong guarantee. However, it comes at a huge cost to utility, and that makes these models unusable in the case of generative modeling. So we wanted to kind of like borrow some of the same ideas without providing like such explicitly strong guarantees. What PrivGAN does is it borrows from the notion that you don't want any one sample or any one sample to kind of like overwhelmingly kind of like dictate the model generate like the data generation process. But instead of like one sample, we loosen the definition and make it a subset of samples. So what happens in PrivGAN is, when you get data set, you randomly partition it into multiple non-overlapping parts, and then you train a generator and a discriminator to each part of this data, like each split of the data. And the only like thing that you do differently from a regular GAN training is there is a centralized adversary which only looks at synthetic data generated from each generator, but tries to identify which generator generated it. And so each generator now not only tries to fool its corresponding discriminator, which would be the case in a traditional GAN, but it also tries to fool the centralized adversary. In our paper, we demonstrate that this is mathematically equivalent to the distributions learned by the generators being forced to be similar to each other. That indirectly prevents overfitting to a subset of samples or like to like any one sample. And so while PrivGAN does not have like the same kind of explicit guarantees as differential privacy based approaches like DPGAN, but we compare privacy versus utility trade-off in these different classes between PrivGAN and some of the competing approaches like DPGAN and PateGAN, and show that PrivGAN does a lot better in terms of like for the same level of privacy loss, same level of empirical privacy loss, you have a much higher utility.
That's very interesting and powerful, because in the end, utility does matter a lot. So, as well as privacy, of course. Now that you mentioned that, was one of the things that you mentioned earlier that also ring a bell, which is you mentioned how GANs can link information when attacked. I guess we can extend that to machine learning in general. So, can you explain, first of all, how have you identified the possibility of those attacks, and specifically, what are in the end these membership inference attacks and how do they work?
Membership inference attacks are they're very simple attacks in their aim. In a membership inference attack, you assume there's an adversary who has access to a large amount of samples, and all they want to know is if any of the samples that they have were used to train the machine learning model that you're exposing to the world. It could be a generative model, it could be a discriminative model. You're completely right. There's nothing unique about generative models here. It could be any model. People initially assumed that models like GANs were not at risk to such attacks, but turns out they can also be very vulnerable. When you share the model parameters, for instance, of a GAN, the adversary can use the output of the discriminator, which is the probability that a sample is a real sample or not, to identify whether the sample was in the training set. And the reason this works is because, like all machine learning models, the machine learning models don't quite understand what a class is, what is a real sample. Their notion of classes and real versus fake or whatever is determined based on what they see. So in the case of a GANs, what a GAN thinks is a real sample is actually a real training sample. So the discriminator of GAN will assign a lower probability to real images that were in the training set, a higher probability to real images that were in the training set than those that were not in the training set, even though they were real images. An adversary can utilize this information to identify which were in the training set versus which were not. And you can also, there are attacks that are published which can use synthetic images to do the same thing. In healthcare settings, such attacks can have, a lot of cost in as it might leak information about whether an individual was, say, in a clinical trial, which would give an adversary information about a person's health conditions. So I hope that answers your question.
No, no, it was perfect for sure. Now that also got me curious just on one bit. We know that generative models, regardless they are adversarial or not, they're able to generate data. So in the end, what do GANs bring new to this space, in your opinion?
I wouldn't consider myself really an expert on GANs. I mean, like I've worked with GANs for as long as I've worked on privacy. Based on the work that I have done in this field and my reading of the papers, GANs are more versatile and less constrained than some of the other approaches that existed in the field. More recent approaches like variational autoencoders or probabilistic graphical models, which have been around forever. Particularly in the case of images, GANs seem to generate better quality images than a lot of these other approaches. There have been a lot of comparisons between GANs and variational autoencoders, and it seems like like now it's conclusively understood that GANs generate better quality samples, which again lead to higher utility for downstream tasks.
A lot of the generation of synthetic data, especially on the GAN level, has been explored for the images, and how they determine the quality is also how good they look. I think for me and Sumit, we are more interested in a different kind of what we call utility. It's not so much how good they look, but how helpful the image or whatever the synthetic data is. So that's kind of also a thing that we're exploring. Yeah, we're starting with GANs, but maybe there's no clear winner yet if for other generation process.
That's a very interesting point, and in fact, that makes me recall of, I think, a research article on generative teaching networks, which in the end they generate images that for a human eye they don't look like real. So if I go and validate them, they don't look right like real images. But they, in the end, and further down on the utility in using them for machine learning processes, they still do give the same results or good results in terms of. So that your point, Jean-François, does remind me a bit of that research paper
The evaluation of utility is still, I think, an open. Uh,
discussion. Yeah, definitely. And on that sense, and picking up a bit on your research, which is it's another level of the same problem, let's say. I feel like, can I categorize your research as federated privacy preserving synthetic data sharing?
yes,
It is?
yes. I think
Yeah.
I often have problems finding titles for my papers and presentation because it's too long. Yeah, yeah, that's the point. And I mean, I'm currently very focusing on everything based on what Sumit has started. So not being a theoretical person like Sumit is, I looked at his paper and first thing I went to is the graphics. When I saw the diagram of PrivGAN, to me it was I thought it was already a federated learning paper because you have these subsets, you divide the data into subsets and then you learn on it. But in the original privgan paper, that was like the main focus was privacy. But and I saw like a clear extension, and I'm sure I wasn't the only one. You see this, you already think of federated learning. I might mention also that like very often when people think of federated learning, they think of maybe Google, for example, learning from millions of phones. We are more interested into like much less participants. It would be like few hospital. Like it could go to, I guess it could go to 100, but usually our exploration goes to a much lower, much limited number of users, even two actually. So the typical scenarios that we are interested is that we have one, let's say an hospital, or in the paper that I mentioned, it was actually a bank. You have one data owner that has limited data. We try to find a way to have this data owner be held by another data owner with these limitations that you cannot share your data. So we kind of adapted the privgan architecture into to have a different subset. So in the original privgan paper, they are just randomly separated disjoint subset of the original dataset. In that case, we created artificially biased or reduced dataset and see how much it can help. And the nice thing that we found is that sometimes locally you cannot even generate synthetic data at all because you don't have enough data. But if you connect with this central discriminator that Sumit mentioned to another data user, then you can generate actually a good enough data, especially if you don't have enough. And something that we're working on right now is actually also helping bias of your data. Let's say you have a data set where a health data set with some population where you have only young people, maybe your children hospital, for example, and then you want to train a model, but you have images of young people, then you can connect with another hospital that has a different distribution, maybe with a more general hospital with people of all age, and then that helps you generate a more generalized data set.
And having that way of sharing information in a decentralized way and having this centralized generator, do you feel like this is something that really can make innovation in the healthcare sector go further, go for another level? You mentioned that's definitely a problem, the ways of sharing data, but do you think this is one step further into getting closer to evolve healthcare and the use of machine learning in healthcare?
It's still at the very research level. We're playing on toy data sets, and we have just started working on more complex data, physical data and images, and that's quite a challenge because you see all these beautiful images from GANs, like for example this website, this person does not exist, really looks like a person, but they trained on a huge amount of data, and they usually used very well curated data set, which is usually not the case in the healthcare domain. So the data has very often there's some artifacts that depends on when you where you got the data, and also the diagnose, how the labels are done. It's it changed from place to place. Everything looks very nice on our first exploration, but it's quite a challenge, and we need to do it in collaboration. It's definitely not a job only for a machine learning researcher. We're starting actually a collaboration with Sumit. Well, with Microsoft, BC, British Columbia Cancer, Fred Hutch. It's called the Cascadia Alliance, and then we will try to generate synthetic data from real images in this collaboration setting. But that's very ambitious. We will have to go through a lot of pitfalls before reaching a successful level.
I will for sure be interested in following you and your advances in that research because this sounds very promising and I think very interesting for every one of us in the end. Healthcare is something, it's always an important matter for all of us. And now a bit again of a more technical question. I know this concept of okay, there are several different methods of privacy enhancing technologies like federated learning, then it has synthetic data. You combine the both of the worlds, which is amazing. But in your opinion, what are in the end the advantages that federated learning brings that solves in a way the problems that synthetic data might have? And what are the benefits that synthetic data delivers that federated learning is not able to, in your opinion?
If you know that you have only one use case, like you know you want to do one thing, then maybe federated learning is better because you could learn one model in a federated learning way, and then you optimize for this. The benefits for synthetic data is that it's much more polyvalent. So you can use it for even things that you didn't think about before making the synthetic data. You can have people look at the data, you can train models for different labels, you can use it for classification. That gives you much more opportunities, I would say. So that for me, that's the main distinction between the two.
That was a very interesting one. One brings flexibility, another one brings the possibility of keeping everything on the local side, let's say, which is yeah, it's very interesting. And talking about this might be a bit less technical than we covered so far, but from what you have seen in both of your experience, what are the main use cases and utility that synthetic data can unlock and real world data problems from your perspective?
So, technically speaking, I think there are two main applications of synthetic data. One is data sharing in a privacy preserving manner in settings where sharing the real data is cumbersome or impossible. Two, augmenting data sets to increase their size, which can help train better downstream models. Both these applications can be helpful in a wide variety of domains, one of which is definitely healthcare, but it can also help tech companies. So some concrete examples might be to kind of like share PHI medical data between institutes, which is something we've been talking about. But in tech companies, there's also a lot of customer data, which companies tend to like. There's like different levels of protection by company, but like, companies generally don't want to go around sharing non-anonymized data even between teams. You can anonymize the data, then use synthetic data generation approaches to generate synthetic data and share that with other teams instead of like sharing actual data. And if a company wants to kind of open source some of the data sets to, for whatever reason, many companies do that for the purpose of like bringing, like pushing forward science. In that case, it might benefit. Sharing synthetic data might be less risky option than actually sharing anonymized real data, because there are like notable cases like the Netflix rise where companies thought that Netflix thought that they were sharing anonymized data, but some smart adversarial researchers found that you could join that with other similar data sets and identify who the individuals were. So to kind of like prevent things like this from happening, maybe synthetic data could be helpful.
One of the challenge of synthetic data is data quality or utility, but if we can think of a use case, even if you're generating not so good synthetic data, so there's some applicability for this too. So for example, if you have a system that process data and you want to test it, if it can sustain a large amount of data, then you can generate a large amount of synthetic data instead of collecting a large amount of data to fill it. And if it's just you want to see if your system can process it, then you don't have to have that good data. Another thing also is that was from last year, a paper from Google that they use actually synthetic data for debugging the data of or do some debugging exploration of the data. So usually when you make a model and your model fails completely to over some subsample of the data for some reason, like the first reaction is to just look at it, look at the data, what's wrong, but you just can't do it. So one thing is that, okay, what's wrong? What's so different in this subset of the data? You can train a synthetic data generation model, and then you can see, well, the example they gave was that for the image everything was flipped, so black was white and white was black, so you don't need a very good data generation to find that out. And they had also another example about the word NLP problem, and then there was the stop word definition, so the some words were like combined together, and then you can see that very easily. Yeah.
That one for me, it's a novelty. That's fantastic.
Yeah.
Using synthetic data as a debugging mode, it's quite impressive.
Yeah, it's a lovely idea because what I like is that you don't need good data for good synthetic data, and
Exactly.
usually the problem.
Yeah, exactly. Yes, that's you just need to understand the overall issue, and that's it. So yeah, that's amazing. Definitely, I heard the use of synthetic data as a compression method that I have heard, but that one for me, it's completely it blew my mind, to be honest. Amazing. How much bias can synthetic data introduce? In the end, is this a particular problem for synthetic data, or in reality, this is really a concern when building any machine learning solution?
There are like certain bias concerns that are unique to synthetic data generation methods, I would say, particularly GANs. There's something called mode collapse where what happens is your data set has like a like a diversity of samples, but during the training process, like your model somehow only like after a point just starts to kind of like generate like a certain subset of samples and does not kind of like generate samples from like the other parts of the distribution anymore. That is actually quite a common problem in GANs. There have been certain solutions proposed. Methods like Wasserstein GAN and PAC GAN are supposedly they suffer less from mode collapse, and there's like this is an ongoing area of work. There's also this like fairness implication, but that's kind of like more related to any machine learning. Like fairness implication of privacy. When you're trying to provide privacy to a model or a data set, what you want to ensure is that people can't be identified. As it turns out, the people who are at the highest risk of being identified are people who are kind of like not like the like the average person in the data set, but the outliers have a higher chance of being identified. And so the privacy preserving approaches, what they tend to do is they obscure samples based on their privacy risk. And since the outliers are at a higher risk for privacy leakage, they get obscured more. What this leads to is both in the synthetic data generation process, they might not show up in the synthetic data set at all. And in case of regular machine learning, if you're training a classification model, for instance, and in a privacy preserving manner, the performance for outlier samples might become way worse than your general performance on the data set. In terms of synthetic data, this is also a pretty serious problem because a lot of times like the outliers would suffer a lot from imposing privacy, I guess.
I've kind of had the same idea that Sumit was sharing. There's actually ways that you can think of sharing data can try to fix bias. For example, if if we go back to GANs, you train a GAN, and then if you have a conditional GAN, then you can generate more of a class that is underrepresented. You cannot be better than the data that you have. So if you have a very few sample of those outliers, whatever you will generate will look super similar to what you had. So hopefully that sharing data would help, and that's one of the hope that like improving the sharing of data will help reducing some of the bias.
For you, in areas such as healthcare, the introduction, I have this idea that the introduction of new tech solutions is always challenging. So it's an area where there is a lot of risk, right? So everything that is new has to be very well tested. So in your opinion, is do you think this vertical is ready for synthetic data adoption?
There is a lot of interest. I believe it will take some time. Our work, and when I say our, it's really collaboration with Jean-François and others at both University of British Columbia, within Microsoft, Fred Hutch, and other organizations. What we're trying to do is we're trying to do proof of concept demonstrations on the utility of synthetic data in different settings in healthcare, and hoping that this will convince first the regulators and then also convince clinicians to adopt synthetic data as an alternative to traditional data sharing. Luckily, from the side of the clinicians, there already seems to be a lot of interest. Like a lot of clinicians now actively want to explore machine learning. So there's like a lot of interest there, but they are kind of like stuck in their inability to share the data. And they also recognize that, like there are a few medical image data sets out in the public domain, but not representative of like models trained on those will not work very well on like the actual data that they have because of like biases between centers, and there's a lot of specificity of medical data. So the clinicians are like largely kind of like excited about this. The regulators are the ones who need to be convinced. I'm quite hopeful. I think like if we are able to do a few good proof of concept demonstrations, then there might be a good case to be made to the regulators.
I might add that through this collaboration we have this is such a nice and diverse collaboration. There we have some lawyers also included, and they are trying to reach out to different health organization, to their legal team, and try to find out what's their worst worries about, for example, privacy leaks or a membership attack. And it turned out that, well, I don't know if I say it like correctly, but like they don't care because they're not aware about it. They're worried about sharing real data. So that's for sure. That's the inspiration of all this work. It's still not part of the bureau, like the ethical bureau or whatever, to make sure that these leaks are going out. So it feels like when we're pitching this to them, we're fixing something that is not broken. But so I think that's one of the challenges, that if the hype gets too big and gets installed, that's a vulnerability that has to be addressed before it gets deployed, and make sure the education is done too.
That's a very interesting perspective because, in the end, how can you convince someone that they have a problem if they are not even aware of it? And how do you tackle that? Definitely. Sumit and Jean Francois, I have to say this has been a very interesting conversation. But before we say the goodbyes, we have here in the podcast the section that we like to call the open mic, when we share some ideas, views, or even awkward stuff that you have already seen that you are able to share, you would like to share. Do you anything in mind that, well, you can recall and like to tell to our community?
Data is like money, like everybody's showing it off, but nobody wants to share it. Even within organization, that's one thing that I didn't mention, but it happened to me a lot, that somebody would tell me, "Oh yeah, yeah, I can get that data. Don't worry. It's just from the colleague next door." And then he comes a week after. He say, "Oh, sorry, I never knew I could not look at this data." So even within organization, synthetic data could make sense.
I did my PhD in the healthcare domain, and like I've been working on this for a long time, but I've mostly worked in like a very academic setting. So a lot of like benchmarks were clean and like, the data came to me processed. In the course of like working with actual data from, hospitals, I've come to realize that there's a lot of intricacies in healthcare data that need to be accounted for and need to be understood. So I think like one of my biggest learnings while working in these projects is that when you're working with healthcare data, either for synthetic data generation or like, other machine learning projects, it's very important to work with actual experts in the field. Data scientists are not a substitute, or like research scientists are not a substitute for actual healthcare experts. And to really take the needle forward on, any healthcare related technology, for instance, in this case, synthetic data, you have to work with people who are experts. You have to convince them that the technology is useful, and a lot of times they will have like important understandings about the shortcomings of the techniques that you as a non-expert might not have. So that for me, like that was a huge learning, and I hope like, more people working, more machine learning folks working in trying to get into healthcare keep that in mind.
Machine learning can be really powerful, but it needs to come from real world understanding for sure. So, Sumit and Jean Francois, I have to really thank you for your availability to be in this podcast today. It was a pleasure. I will leave your information and your research link down below for the ones that are curious to know more about PrivGAN, federated sharing of synthetic data, and other subjects and projects that you are working currently. Once again, thank you.
Thanks a lot.
Thank you so much, Fabiana. It was a pleasure chatting with you.